Myself Ashigla Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about the subject CS3401 algorithms. In this subject, today we are going to discuss about the topic graph coloring algorithms. So what is the outcome of learning this particular topic is, on successful completion of this module, the student should be able to illustrate the graph coloring algorithms. So next we are going to discuss about what is graph coloring. So this problem, the graph coloring problem, involves assigning a colors to certain elements of the graph subject to certain restrictions or the constraints we have. In the other word, it is a process of assigning a colors to the vertices. The condition is that there is no two adjacent vertex have the same color. See, if there is a nearing vertex means there are neighboring vertex means the neighboring vertex should not have the same color. You have to color all the nodes of the graph, but the restriction which we are having is the nodes or the adjacent node should not have the same color. That is what we call it as the graph coloring problem, or we can say it is a vertex coloring problem. So before doing this, we have to know some of the important term, that is chromatic number. What is chromatic number is the smallest number of color needed to color a particular graph G is called as a chromatic number. For example, in this above image, this vertex can be colored with minimum of two colors. This vertex can be colored with minimum of two colors. For example, we can color with blue and orange. So what is the chromatic number of this graph? The chromatic number of this graph is 2. Similarly, we can see some examples. So what is the chromatic number for the first graph? Because all these three vertex are adjacent to each other, so that we have to give three different colors for the vertex. So what is the chromatic number is 3. So for the second graph, the chromatic number is 2. For the third graph, the chromatic number is 3. And for the fourth graph, the chromatic number which we are using is 2. That is, we have to use 2 colors. So you should remember only one thing, that is, to know two adjacent vertex should have the same colors. So next we are going to discuss about what is the application of this graph coloring. So the application of graph coloring is map coloring, scheduling the task, or preparing timetable, assignments, and conflict resolution, and Sudoku for doing Sudoku. All these things are the applications of this particular graph coloring algorithm. So we have two approaches for solving this graph coloring. One is brute force approach. So it's the simplest approach to solve the problem. So what is brute force approach is, we'll try all the possible combination, and we'll try all the possible combinations of color, and we have to check whether the two adjacent vertex are not in the same color. Finally, you have to derive the solution. But it takes much amount of time because the complexity of this particular problem when we are using brute force is high. So the next approach is the backtracking approach. So in the previous case, that is in the brute force approach, we will try all the possible solutions. But here now we are not going to use all the possible combination. Instead, we are going to use a state space tree. So we are going to ignore some of the branches if it won't leads to the solution. So we always in backtracking approach, we will try a particular possible way. If there is a solution means you can use it. Otherwise, you can backtrack to the previous step, and we have to find out whether there is any solution, or we have to do the, once again you have to do the backtracking and you have to perform the operation. So in backtracking approach, how we are going to do this graph coloring is, the idea is we have to color the vertex. While coloring any adjacent vertex, choose a different color. Similarly, color every possible vertex following the restrictions which we have mentioned earlier. So till any further vertex is left non-coloring. So we have to color the entire list by using this method. So next we are going to discuss about the algorithm. So this is the state space tree. So first you have to draw the state space tree. In each branch we have to check whether it leads to the solution. If there is no possible solution means you have to backtrack and you have to try the next way. So this is what we call it as graph coloring algorithm. So this can be solved by using backtracking approach also. Thank you.